Okay, so drooping characteristics means it tries to keep the current constant. In flat type, it tries to constant the voltage. And number three is rising voltage type. Now we will learn when and where this type of characteristics are used. In normal MMA weldings, always drooping characteristics are used. So this drooping is used in MMA welding, manual metal arc welding. Drooping characteristics is used. Why? Because when in MMA arc welding we start the arc, we initiate the arc, then we touch two electrodes, and as a result there is a huge current surge in the transformer or in the DC machine. So in such case, to withstand that surge, the machine is kept so in such a way that it tries to keep the constant, it tries to keep the current constant. So what happens, I'll explain with a curve. A drooping characteristics, the curve look like this, where this is voltage and this is current. Now then you will ask, where then it is constant current? But actually this is actually open circuit voltage. If we look at 2 points, then you will find for a larger change in voltage, the change of current is very little. So change of current occurs, but it affects very little with compared to voltage. So this is a drooping curve. When you when you go for a shorter arc, suppose we are reaching from shorter arc B and converting to longer arc A, that means when you are welding, you are shifting your electrode away from the workpiece, and then what happens, the gap increases and the arc length becomes longer. In such case, B is for shorter arc and A is for longer arc. In such case, if you look at it, the voltage rises but the current changes very little. So to continue to prepare a stabilized arc, the voltage increases and the current remains almost same or decreases a little value. Okay, so that's why it is called constant current. Now this type of uh, curve, this type of characteristics is used in MMA welding, in TIG welding, in submerged arc welding, and also plasma arc welding. So this is used in MMA, TIG, submerged arc welding, and as well as plasma arc welding. Okay, now so whenever we are changing the gap between two electrodes, then if the gap changes, the current also changes, and to keep the current constant, the voltage changes. That is the characteristics of these particular machines. So those machines which are using drooping characteristics, they tries to keep the current constant by changing the voltage. And why we need to do that? Because when we are doing manual metal arc weldings, we cannot fix the gap between two electrodes. So there will be variation, and if there is variation, the voltage will be changing accordingly to keep the current constant, to keep the arc stable. So if the gap becomes lower, the voltage also reduces, and if the gap becomes higher, the voltage increases to keep the current constant. And the open circuit voltage, OCV, for this case is about 80 volt, and when welding is going on, welding voltage or working voltage is 30 to 40 volt. Now secondly, if we this is the first one, drooping characteristics. This is the second one, flat or constant voltage type. Here the curve will look like this. Here the curve will look like this, and in this region, if you look, the current will change much higher value. This is current, this is voltage. I'm writing ampere, which is not right. It is actually current. I need to write, but it just ampere values are giving current, so I wrote it. I do not want to cut it. I hope you understand. So this is the same scenario where we are changing from a shorter gap to a longer gap. We are shifting. As a result, you see the change in voltage is very less, but the current has been changed a lot. So this type of characteristics are called flat or constant voltage. So here these MMA weldings mostly used for normal manual usage, manual weldings. In this flat or constant voltage, these are used in semi-automatic like MIG or some automatic processes also. Okay, and this rising voltage type, that curve looks like this. So for if you see the voltage is rising, and this is called rising voltage characteristics or rising curve. So here this is V, this is I. Now this rising voltage type are used with fully automatic welding processes, and the open circuit voltage is 70 to 80 volt, and this current is controlled. This may be used in AC, may be used in DC, both are used, but in DC also the current is controlled in the AC section before it reaches to rectifier. Please try to remember this point. We do not change any DC current. Whatever we need to change on the current characteristics, we change it on the AC portion before it reaches to rectifier. When it goes to rectifier, the current is fed or used to welding. Now there are several ways to change the current. So I'm writing this point here. Current is controlled in AC portion before it reaches to rectifier, and we change the current properties by variable inductance or impedance. Various methods are used for that. Methods of changing the impedance is different principles are used. Number one, moving shunt. Number two, tapped reactor. Number three, moving coil. Number four, saturable reactor. Number five, moving reactor core. So there are different methods to control the impedance or use the varying impedance, and these are the methods we normally use. Okay, these all are inside the transformer or the rectifier. Now for different welding plants, that means for different welding machines, depending on the process and the job and the environment, our requirement, we choose any one type between them. Okay, our next topic is carbon arc welding. In carbon arc welding, the joint is produced by hitting the workpiece with producing an electric arc struck by a carbon electrode and the workpiece. So we use a carbon electrode, and the welding is carried out in air, maybe in air or in an inert atmosphere. Inert atmosphere means there are inert gases to be produced from a cylinder through the electrode holder. Now, so in carbon arc welding, we can understand that the carbon is basically a graphite rod. This is the electrode holder which will be connected to negative side, and this is your job, and this is connected to positive side, and this length is generally kept 50 to 70 mm. Okay, this is carbon electrode, and this is your holder. Okay, now so in carbon arc welding, we normally use DC current, and polarity is preferred is straight polarity. That means electrode negative. Why? Because if this is negative, then the electrons will strike on the job and the most heat will be generated on the job. If any filler material is to be provided, then that filler rod is held by some method at an angle of 30 degree, around 30 degree between the arc flow. So this is filler rod, and this filler rod is similar with the parent metal. Now, why we use this type of polarity? Because we need to generate most of the heat on the job. If we generate heat on the workpiece, if we generate the most of the heat on the electrode, then electrode will be affected and electrode will be, burn away, because the graphite is not so, very strong material. It has good current conductivity. Sometimes these electrodes are kept copper coated.
Sir, 70 mm, sir, is the electrode distance between the workpiece.
70 mm is the distance from the electrode tip to the electrode holder. 50 to 70 mm.
Okay, sir. Okay, sir.
If it is very long, then the carbon electrode is weak and it may break, and because it will not withstand much bending moment or much, it may break. And if it is very small, then there is a chance of short circuiting.
Sir, thank you, sir.
Okay.
Yes, sir.
Now, whenever we join this type of welding, this carbon arc welding, then we use a backing strip to keep the job in place. So when you are adding this, we use a backing strip. This is called backing strip. A piece of metal, in case of lap welding also, the use of the backing strip is to fixing these two metals before welding. So it has a several use on, these are normal butt joint. This is a lap joint. You all know that. Do not need to discuss much about it. This is new. This is called corner joints. Now here, this portion to be welded, and for that purpose we use a backing strip like this. So this is here the backing strip to support the two metals, to fix the angles between them. Now these type of joints are made in carbon arc weldings. These T joints or fillet joints, okay, this type of edge joints, these type of joints are also done. This is called edge in carbon arc welding. So T, flange, lap, corner, all can be done in your carbon arc welding. There are two type of settings. One is single electrode and twin electrode. And the shielding purpose, the gases are used normally: argon, helium, nitrogen also. Now this nitrogen cannot be used in tungsten inert gas arc welding. So it cannot be used in TIG because nitrogen attacks tungsten. Okay, so you have to be very careful when you are choosing your shielding gas. And as well as in some cases CO2 is also used, because CO2 is very cheap. But there are
Hello,
some.
sir.
Yes, bolo.
Yes, sir. I was saying that. Can you please explain which category does this single electrode and twin electrode fall in?
It depends on the job. When you require less heat, then single electrode is enough. When you require more heat, then you need to throw more electron to the workpiece, and then you use multi-electrode twin carbon arc welding that can be used. And there are some adjustments also. Is it looks like I'm trying to draw it. The electrode holder is a little special type. I don't know if I can work with or not. The electrode holder look like this when there are twin carbon arc welding electrode holder is this twin carbon arc electrode holder. If you need to generate more heat on the workpiece, or we need more penetration, we have a very thick job, then we go for this twin carbon arc electrode arc welding, and this is the holder. Now AC and DC both are used, but in most cases, maximum cases, only DC and electrode negative is used. In some cases, when these electrodes are having copper copper outer cover for helping the to rise the conductivity and withstand more temperature, then AC can be also used. But most useful practice is to use it on straight polarity in DC. So equipment used here is high voltage DC generator or transformer. High voltage DC generator or transformer. Number two, the electrode if gets heat, of course it gets heat, but if it goes very high, then graphite cannot withstand that, and for that the electrode have holes, passages to pass water. So it may be water cooled or it may be air cooled.
Sir, এগুলো কিসের equipment?
Carbon arc welding এ
Okay, sir. Thank you.
copper coated or copper coated carbon or actually graphite electrode is used. Filler rod to be used if needed separately. If the thickness is lower, then we do not need to use separate filler rod. If the thickness is more than 3 to 5 mm, then we go for filler rod. Okay, any questions on carbon arc welding? No questions. Okay, then we go for our next topic, which is metal inert gas arc welding or MIG. In MIG, there is inert gas cylinder with a valve and there is a indicator which is give you the pressure, which will give you the pressure inside the cylinder, and looking at the pressure you can understand whether it is safe or not, if there is gas is already there or not, and there is a valve or regulator to control the gas flow, and there is a hose pipe coming out from it, and it directly goes to the welding gun. And there is a wire spool to be connected. These wire actually used as a consumable electrode, and this is guiding tube, and here there are two rollers. These rollers actually pulling the wire from the spool. So, and there is a control device. This control device again connected with the welding gun, and there is a roller which is connected to this control device through a controller. Now here then there are several inputs, and this is the say job. Okay, so this is inert gas cylinder, this is metal wire or filler wire spool, this is the welding power source with controller, this is wire feed controller, and this also, this welding power source with controller, this also controls the gas flow rate. Okay, so what happens here is the controller controls everything, and before you go for welding you have to switch on the inert gas and set up flow parameters. You have to
Sir,
yes.
sir, welding power source controller control the gas flow rate. Sir, we can sir control the gas flow rate with the cylinder.
with the valve itself, you know, but there is a digital control system, PLC system inside that controller machine, and whenever we set that particular value, and that valve associated with the controller system opens in such a way that our desired value of flow rate can be achieved. And there is another safety valve which is on the cylinder. If you close the cylinder valve, then the gas flow will be also again closed. So we have to open the gas cylinder in a pressure below the maximum pressure, maximum operating pressure, and as well as you need to control the gas flow rate and where feed rate to the I mean with the controller associated with the welding power source. So this machine, this controlling section, this controls two things: one the gas flow rate, second the wire feed rate. There might be separate switches, there might not be separate switches. Okay, it may be you have to just put the values in digital formats in your controlling section. There is a small LCD display, and there you can see the values and you can change it and put it, enter it, and then the machine's PLCs will understand that value, and as a result they will control the wire feed and as well as gas feeds. Did you got your answer?
Yes, sir.
Okay. Here argon is used, helium is used, CO2 also used. This is a consumable electrode process. Now the principle of operation is such that whenever you turn on the machine, first you need to set the gas flow rate or and the wear feed rate, otherwise the machine will not work. In some cases, in some machines, they might be uh, catching up previous used values. That depends on the machine controllers, manufacturers. So whenever you set all these values, then you turn on, and then upon pushing the trigger on the welding gun, this is called welding gun. Then the wire comes out in front of the welding gun, and then when the wire comes out for a very little, about 1 inch or 2 inch, then we scratch it or we touch it on the surface where we want to weld. Then the arc starts, and as the electrode is a consumable electrode, which is basically the metal wire, sometimes copper coated on the outside, and then it get burnt, I mean it get melted, and then forms droplet and gets into the welding metal pool. And as you continue your welding, the wires will be coming out. Now sometimes the welding gun need to be cooled, and sometimes the air cooled system or the water cooled system is also used, but in most of the cases we do not use water cooled. Air cooling is sufficient as the electrode to be melted. So we do not need to use cooler here, or water cooling system is not required in most of the cases. But after welding for some particular time, you need to wait to cool down of the welding gun. So suppose it has a duty cycle. After using 10 minutes, you need to wait for 2-3 minutes to cool down the welding guns. Otherwise the welding gun will get heat and it may be damaged. Now the torch should be 10 to 12 mm away from the workpiece. This should be 10 to 12 mm away from the workpiece. And the arc length to be kept 1.5 to 4 mm. Now equipment required. Equipment requires in GMAW, gas metal arc welding, that is welding power source with cable, welding gun, these wire can be fed in two types of systems: wire push and wire pull. Okay, or wire pulling system is the most used one. What we have in our college, there is a wire puller. By help of two rollers, it pulls the wire from the spool. The spools can be let me write here. Wire spool. This is available of several dia and for several weight, like 1 to 15 kg is available in market, and its diameter, wire diameter, is about 0.8, 0.8, 1.2 mm, 1.6 mm, and 2 mm. This type of diameters are available in the market. If you want a special diameter, then you have to order it to the producer. Okay, then next we require shielding gas cylinder.
Yes. Sir,
What?
what is the affected of the diameter in the welding?
If you require more deposition rate, or you are welding a very bigger or thicker material, bigger thicker jobs, then you need very high deposition rate. In such case, you have to go for the higher diameter with higher currents. Otherwise, if you use small diameter wires, you need very long time, and in that time the welding gun will get hit. So whenever the gap is bigger, whenever you need to fill more material, then you need higher deposition rate, higher melting rate. So in that case, you have to use for higher currents, and you have to use bigger diameter wires. Okay.
Okay, sir. Thank you, sir.
Okay. So gas cylinder is required, along with pressure regulator is also required for safety purpose, and flow meter should be there, because we cannot rely on the electronic system all the time. Electronic system works fine, but anytime it may fail. So there should be another safety mechanical system. So looking at the flow meter or looking at the pressure regulator indicator, we can find out what is actually the situation inside the cylinder. So to avoid any type of danger, we also attach all these things with the cylinder, and as well as we can see this, we can set the values in the controller. So there should be a control switch for everything, or emergency stop if any situation happens. Power source, or maybe AC. This is another topic. Power source. This might be AC transformer, or might be DC generator. Now usually drooping current characteristics, or sorry, I mean drooping characteristics is used when we use electrode negative. Then we can get deeper penetration. Direct current electrode negative gives you deeper penetration. The power source is generally rated as 60% and 100% duty cycle. That means it can be work anytime you want, full time you want. Otherwise, in a duty cycle, you have to work by 60% of time, and you have to rest. You have to keep the machine keep resting by 40% of the time. So if you using say 1 hour, then 36 minutes you can use, and the rest you need to keep the machine stopped condition. That is for 60% working cycle. So the machines comes with two types of duty cycles. And for automated, this is for manual. For manual MIG operation, drooping characteristics used. For automated MIG, rising voltage type characteristics is used. But in some cases we require lesser heat. In such cases like aluminium, magnesium, we use electrode positive. So whenever you want to weld, automatically it will not work until you turn on the gas flow and the uh, wire feed value. So the variables here, variables you need to set is then wire feed rate, number 2 gas flow rate, number 3 electrode stick out, how much the electrode is came out from the gun. Okay, electrode to work angle, this is for automated purpose. Electrode to work angle, which is kept about 70 60 degree, and nozzle to plate or work distance. These all to be set in an automated system. Okay, we will stop here as the time is up, and from the next class